Yes, this is question number 31, second subdivision. The question is this: x power 8 minus 3x plus 1 is equal to 0. What is the question actually? Examine the rational roots. Find the rational roots of this equation. Examine the rational roots of this equation. Now actually we should know this rational root theorem for doing this sum. First I will explain this rational root theorem, then we will see what is this problem. Let this be a polynomial. An is the coefficient x power n, plus it goes on, the power decreases, a1x, this is the constant term a0. What this rational root theorem says is, suppose if p by q is a root of this polynomial, rational root of this polynomial, then p is a factor of a0 and q is a factor of an. So these two lines are important. P is a factor of a0. What is p? The numerator should be the factor of this constant, and q, the denominator, should be the factor of this coefficient an. If that is the case, if p is a factor of a0 and q is a factor of an, definitely p by q will be a root of this equation. That is what rational root theorem says. I will repeat. If p is a factor of a0 and q is a factor of an, with p and q is equal to 1. What is the meaning for this? Means the common factor between p and q should be equal to 1. For example, if p is 3, q can be 5, because there is no common divisor between 3 and 5. If p is 4, q cannot be 8, because common factor for 4 and 8 is 4. It is not equal to 1. So try to understand the theorem. One polynomial is present. The first coefficient is called an. Constant term is called a0. We will say p by q, that is a rational number, is a factor, is a root of this polynomial when it satisfies this condition. What condition? P should be a factor of a0, q should be the factor of an. The second condition is there should not be any common factor between p and q. P and q, if I take common factor, the answer should be 1. So this theorem gives us the authority of getting a rational root. So for this sum, I am going to apply this theorem. Now see, what is an here? First coefficient, right? 1. What is a0? Last coefficient, that is also equal to 1. So here p must divide 1. If at all any root is of the form p by q, this p should divide a0, q should divide an. That is, p must divide 1 and q must divide 1. So when it is possible values of p are plus or minus 1 and possible values of q are only plus or minus 1, right? Therefore p and q can form only fractions plus or minus 1 by 1. Can you guess how it is, or getting confused? According to the rational root theorem, for this sum, this p should divide 1, q should divide 1. What are the number which divides 1? Only two possible, plus 1 and minus 1, right? The number which divides 1 or which is a factor of 1, what should I say? Actually p must divide this 1, q should be a factor of this 1. Definitely factor of 1 is, I can say only plus 1 or I can say minus 1. Only two possibilities, no other number I can say. So the only possible values of p and q are either p can be plus or minus 1, q also can be plus or minus 1. So if I find p by q, I will get only this answer, because both p and q are only equal to plus 1 or minus 1. So whatever it is, if both are plus 1, the root will be 1. If both are minus 1, then also root will be 1. If one is plus, other one is minus, the answer will be minus 1. So 1 and minus 1 are not roots, right? But here 1 and minus 1 are not roots. But if you see this, the only possibilities are either plus 1 can be a root or minus 1 can be a root. but it is not possible because see the question, find the sum of coefficients. For this I am writing the reason. What is the reason? Sum of coefficients is what? 1 minus 3 plus 1 minus 1, which is not equal to 0. Therefore 1 cannot be, 1 is not a root. Now see odd coefficient and even coefficient. Suppose if I take this 1 and last one is 2, 1 plus 1 is 2, and even odd coefficients I have taken and added it as 2. Even coefficients, if I take, only minus 3 is present. Since these two are not equal, minus 1 cannot be a root. Try to understand, children, don't get confused. Just first go through what is rational root theorem. P should be factor of a naught, Q should be factor of an. There is no common term, there should not be any common factor between P and Q. This is the condition. If these conditions apply, then I can say P by Q is a root of this equation. Similarly, for this sum, a naught is also 1, an is also 1. So P should divide 1, Q also should divide 1. So only possibilities of P and Q are either P is plus or minus 1, Q can also be plus or minus 1. So if I put P by Q, what happens? Either I will get 1 or minus 1 as the answer. But 1 and minus 1 cannot be answers because sum of coefficients not equal to 0. Odd and even coefficients are not equal. Therefore 1 and minus 1 cannot be the roots of this equation. Since we will say the given equation has no rational roots. Hence the given equation has no rational roots. This equation will have 8 solutions, but no rational roots will be there. What is the meaning of rational roots? P by Q format answer will not be there for this equation. That is the meaning. Okay, we will see the next problem in the next video.